Hi students, today class we are going to learn about a new topic which is called piezoelectric transducer. Before getting into this topic, what is meant by piezoelectric transducer and its working principle, first we should know what is piezoelectric materials. Okay, so the piezoelectric material is one kind of crystal in which the electric potential is generated across the surface ends when the material undergoes a deformation by the application of external force. Okay, this process of principle is nothing but piezoelectric effect. So piezoelectric material is nothing but is a crystal. When you are giving any kind of force or something, if you are giving any kind of pressure or stress on that crystal, it will undergo the deformation. As a result, you can have a generation of electric potential across the surface of the ends. This electric potential is nothing but it's the output of piezoelectric effect. Okay, so in this way, you are converting what? It's a non-electrical output into non-electrical input into electrical output. Electrical output. Okay, so here what is a non-electrical input? Non-electrical parameter input is either force, pressure, or any kind of stress. Okay, so when you are giving any kind of this on the surface of the crystal, this so the crystal will undergo. What is that crystal? Is nothing but piezoelectric materials. Okay, this that material will undergo some kind of deformation by changing its shape. As a result, there is a creation of charge carriers, which is nothing but potential. Okay, which is nothing but electric potential, which is generated across the surface of piezoelectric crystal. As a result, you will get is a voltage as a output. Okay, this is the principle. Okay, so this is the basic effect, that is piezoelectric effect, which is followed in piezoelectric transducer. Okay, so now you come to know what is mean piezoelectric transducer. The piezoelectric transducer is a transducer which follows the piezoelectric effect. By means of this piezoelectric effect, you can convert the mechanical energy into electrical energy, or you can also say non-electrical parameter into electrical parameter. Yes. Next, we will see the types of piezoelectric crystal. Here we have the two types of piezoelectric crystal based on the availability. One is a natural crystal, that is, it is easily available on the earth, that is a natural crystal. Again, the second one is synthetic crystal. This is the type of crystal we are synthesizing artificially. Okay, that one is synthetic crystal. So, example for natural crystal is quartz, tourmaline, etc. And example for synthetic crystals are Rochley salt, lithium sulfate, and dipotassium titanate. So these are the material which has a unique characteristics of having piezoelectric effect. Okay. So other than this, if you are choose any other solid crystal, it doesn't. It will not have such effect of piezoelectric effect. Okay. So it is very important while choosing the crystal which have the piezoelectric effect, so that only we can perform transduction process, that is from mechanical energy into electrical energy. Okay, so it is very much essential to select or to consider the piezoelectric crystals when you are designing any piezoelectric transducer. Okay, so next is inverse piezoelectric effect. Okay, so the piezoelectric transducer has a unique characteristics that it has a piezoelectric effect as well as it has inverse piezoelectric effect. Okay, you know what is mean by inverse piezoelectric effect? If the in piezoelectric effect, if you are converting no, mechanical energy into electrical energy, means the reverse of that is the inverse piezoelectric effect. So this is the one of the unique characteristics of piezoelectric transducer. Okay, so that piezoelectric crystal has a unique properties. It can follows in two ways. One, by following piezoelectric effect, it can convert the mechanical energy into electrical energy. If we want any other application where you convert the electrical energy into mechanical energy also, you can use the same piezoelectric effect, but it's working under the inverse piezoelectric effect. Okay, so inverse piezoelectric effect, here you are giving the input is, okay, here you are giving input is electrical energy. Okay, so you are applying time varying electric potential across the two ends of piezoelectric material. As a result, the material undergoes some kind of deformation and vibrates with a certain frequency. So the output is you will be having the vibration or in the motion at a certain frequency. So the vibration is nothing but it's a kind of mechanical energy. So this is the output which you will get in the inverse piezoelectric effect. So inverse piezoelectric effect, your input is electrical energy and the output is vibration. Okay, so this is applicable for both inverse and non-inverse in case of piezoelectric effect. This is based on application, we can use either of this. Okay, so let's see how does it work. This is the generalized setup for piezoelectric crystal, piezoelectric transducer. Inside the piezoelectric transducer, you have the unique crystal, that is piezoelectric crystal. You can use either natural piezoelectric crystal or synthetic piezoelectric crystal. Okay, so this piezoelectric crystal under no pressure, it will be remains in proper desired shape. Okay, now when you are giving any type of applied force that is on top of this piezoelectric crystal. Now, based on that applied force, this piezoelectric crystal undergoes some kind of deformation. Okay, so because of the deformation inside the will be the creation of charge carriers inside the crystal. Because of that creation, we will have the voltage drop across the two surface of crystal. That voltage drop is nothing but electric potential. Okay, so once again repeating, you have a piezoelectric crystal. This piezoelectric crystal, on the top you have two electrodes. Okay, I forgot to explain this. You have two electrodes which is placed on above and the below of the piezoelectric crystal. By means of this electrode only, you are going to acquire the output voltage. Okay, so this is the electrode. So this setup is almost similar to the capacitor. Okay, you have a metallic A and metallic B, in between you will be having dielectric medium, right? So this actually replicate the setup of capacitor. So similarly in piezoelectric crystal also you will be having the same setup. On top you have one electrode and bottom you will be having another electrode, in between you will be having the piezoelectric crystal. Okay, so under no pressure, if you are not any kind of pressure, means the piezoelectric crystal remains its original shape. So you will not, there will not be any creation, deformation. So the as a result, you will not have any charge carriers generation. So you will not have any voltage drop across the two surface. That is, you can't measure any voltage potential or potential difference across these two electrodes. Whereas if you are applied any force, that is force in the sense if you are giving any kind of stress or pressure or anything, so when you are giving based on that quantity, and you will have impact on the piezoelectric crystal. So as a result, you can have the deformation. Okay, the shape and size of the crystal get varies. Because of that, inside there will be the creation of charge carriers. Okay, there will have a production of charge carriers. These charge carriers will result in production of electric potential. Okay, so because of this variation in charge carriers, you will have the variation in potential. That potential variation and potential difference is nothing but the output which you will get across the two sides of the electrodes. So in this way, you are converting the input pressure, that is input mechanical energy, into output electrical energy. So this is the one way of converting non-electrical parameter into electrical parameter. So let's see the electric potential expression. So this is the output you will get from the piezoelectric transducer when you are giving any kind of stress or mechanical energy. Okay, so that is E is your electric potential is equal to GT F by A. Okay, so F upon A. So G is nothing but is the voltage sensitivity. It is again based on the material which we are using. Okay, and the G is also stands for K by T. Okay, so how this F by A is being replaced by P here in the sense, we know already the pressure is nothing but force per unit area. Force per unit area is nothing but what pressure. So in place of F by A, we are replacing by P. So GT F upon A is also called as GTP. Okay, so this is nothing but electric potential output. Okay, so the K is the piezoelectrical constant and T is the thickness of the crystal, and F is, you know, that is a force applied. Area A is the area of the crystal surface area and P is the pressure. So P is equal to F by A, that is Newton per meter square, and T is nothing but the crystal thickness. Okay, what is the thickness of the crystal is nothing but a T, and K is the piezoelectric constant. That is again based on the material, we are having the some constant default values. So after when you are applying all these values, you can able to get what is the electric potential of piezoelectric transducer. That is the output of piezoelectric transducer. Next, we will see the equivalent circuit of of piezoelectric transducer. Okay, so here they have given a basic equivalent circuit of piezoelectric transducer, that is the figure 1. Here the source is given as a charge generator, because when you are applying any kind of mechanical energy, what is the first step? The crystal is getting deformed. As a result, you have a generation of charge. So that's why here the source is nothing but the charge generator. Okay, here they have given a charge generator. So a charge is Q is equal to dF. The dF is the change in magnitude of force. Okay, so when you applied any kind of force, okay, based on that change in magnitude of force, you will have respective of generation of charge. Okay, so that's why here the Q is equivalent to they are related with change in force. Okay, so here the Q is change in force. The charge generated is across the capacitance Cp of the crystal, that is the capacitance of the crystal, and its leakage resistance is Rp. Okay, so the charge you have, it has been generated across the surface of the crystal, right? So the crystal here they are comparing with the capacitor, because almost similar like capacitor. In capacitor you have metal A, here you will be having the metal B. Okay, in between you will be having the dielectric medium, right? This is the symbol for the capacitance. Similarly, if you take a piezoelectric crystal also, you have the upside, the top side you will have electrode, and bottom side you have another electrode B, A, B, and in between you have what? Piezoelectric crystal. So it's almost similar like what? Your capacitor model. So that here the charge is where it's creating, it will be creating across the surface of the crystal, right? So that's why here this crystal setup is being replaced by the capacitance, and you have some leakage resistance that we have added in RP. Okay, so here the output you will be measured in across these two terminals 1 and 2. Okay, so this is the generalized and basic equivalent circuit of piezoelectric transducer. Here the charge generator is connected parallel with parallel connection with Cp and Rp, that is capacitance and resistance. Okay, so further what they have done, further now this charge generator is now replaced by the voltage. The reason is, like when the leakage resistance is too high, in order to reduce the particular block, here we have replaced the charge Q. Okay, the charge Q here we have been replaced with uh, potential. Okay, that is the electric potential. So that is why here we have mentioned as E naught in figure 2. So when you are doing so, you are here the connection will have been changed, like here the Cp and the Rp is having the series connection with E naught. Okay, whereas the Q have parallel connection with Cp and Rp, but whereas in second diagram you are having the electric output potential, which is a series connection with Cp and Rp. So this is the other equivalent circuit, or other way of representing the piezoelectric transducer. This is also one of the equivalent circuit. The basic equivalent circuit is the figure 1. So to have some to overcome some drawback or shortcomings, they have remodeled the second equivalent circuit. So in that circuit, they are changing the they have replaced the Q in terms of E naught, and the Cp and Rp they have connected in series connection. So this is also a second way of representing the equivalent circuit of transducer. Okay. So E naught, you know what is the older formula for output electric potential, that is Q is equal to Cp. Okay, so Q, you know, it's already dF, right? That is change in force. So in place of Q you can put dF by Cp. So this is the equation for measuring or calculating the E naught. So this is the overall equivalent circuit of piezoelectric transducer. Next we will see the advantages. What is the advantage when you are using piezoelectric transducer? Means here you no need of any external source, since it is the active transducer. So when you are having any type of active transducer, means automatically you no need of any external power supply for their excitation. So it will automatically self-generating. So it will operate by on own itself. Okay. So that is the first point. Second point is it is easy to handle and use as it has small dimension. Okay, since it is very compact in nature, it can be easy to handle, and you have very good frequency response. Okay, if it has high frequency response, it means the parameters, frequency related parameters can be measured easily. Okay, if you want to measure bandwidth or something, or frequency, you can be have accurate results in terms of frequency domain. Okay, so that's why it has a high frequency response. Next, if you see the disadvantage here, it is not suitable for measurement in static condition, so it is well suitable only for dynamic condition. That is one of the drawback for piezoelectric transducer. And second point is it is affected by temperature. Okay, it is very much sensitive temperature, so it will affect the output result also. So it is one of the drawback. And the output is slow. Some external circuit is attached to it. So the output which you are getting from the piezoelectric transducer, it is very low. That is in very less in strength. So it requires the additional external circuit to enhance the strength of the signal. So that is one of the drawback of disadvantage. So you can't use the output directly for any other purpose. You have to strengthen the signal by means of amplification, or you have to remove any noise or something. You have to do some kind of noise cancellation process. So these things have to be done before processing the signal. Okay. The last point is it is very difficult to give the desired shape to its material, also the desired style. So once it undergoing deformation, when we are subjecting to any kind of stress, then it's find very difficulty to return to recover its original shape or original strength. So that's find as a one of the drawback here. If it's not regaining its original shape or strength, then obviously the second set of readings based on that the shape and size will leads to wrong. Okay, leads to false results. So that is the that also affects the accuracy of the piezo transducer. So it is also one of the drawback to be considered. Okay, so these are the list of disadvantage of piezoelectric transducer. Next, we will see the application of piezoelectric transducer. So one of the well-known application is the microphones. Here the sound pressure. Okay, again the sound is the non-electrical parameter. The sound pressure here is converting into electrical signal and then ultimately amplified to produce a louder sound. So the principle of converting the loud sound pressure into electric signal is nothing but by means of piezoelectric effect. So it is the basic principle which is employed in microphones. That is one of the application. Second application we can use in medical diagnostic. Yes, in medical field, if you see by means of piezoelectric effect, you have so many machines like, for example, sonography and then ultrasound. So these are the principle. These are the machine which use the principle of piezoelectric effect. By means of that, they are performing some kind of scan. So so again the piezoelectric have transducer have very good application in medical field. And even in the commercial application is electric lighter which is used in kitchen. So this also having piezoelectric effect. So the pressure which is made on piezoelectric sensor creates an electric signal. By means of the signal, you can have a flash to fire up. Okay, so this is the one another one commercial application. And third, you can use in inkjet printers, and even in restaurants or airports, you can see the automatic open doors open and close. So this is all because of the this piezoelectric transducer. When the object is when you have the obstacles near to that, means it will open optically. So it will sense the distance. It will sense the obstacles. Okay, so based on that doors will open and close optically automatically, and you can see in landline phones, and even they can use in seismographs. This is the type of branch of science. This is the study where you can measure the vibration. Okay, so this is especially is a branch of science where you can study about the vibration and everything. Okay, so for that, here also they are using piezoelectric transducer. That is, they follow the piezoelectric effect to do so. Okay, that is one of the major application. And last one is yes, these are used in ultrasound scanning, right? So as I have told you already, the piezoelectric effect based piezoelectric transducer have very much very much high application in medical field, especially for scanning stomach area, that is scanning non-inversely. Okay, especially example is ultrasound, and you have even sonogram, everything, right? So this everything is again based on that piezoelectric materials. Since they are using they're having this kind of application. Okay, so that's all about piezoelectric transducer. So Thank you guys.